In this video, let us take a look at how to choose a suitable indicator for titration. In the previous lesson, we have learned that pH curves have a general shape that looks like this. And these curves can be generated by inserting a pH probe into the conical flask with the probe connected to a data logger. By monitoring the change in pH over time, we know that the equivalence point is reached when the pH curve shows a very steep vertical portion indicated like so. However, we do not always have a pH probe on hand, and it might be difficult to determine the endpoint of the titration without a pH probe, and also when the solutions are all colorless. How do we know when to stop the titration? How do we know when the equivalence point has been reached? In such cases, we make use of what we call an indicator. An indicator is a dye that responds to the change in the hydrogen ion concentration. If we look over at the list over here on the left-hand side, we have a range of different indicators and the colors they are in at different pH. For example, Meta orange is red at pH 1 to 3 and yellow at pH 14. It changes color at around pH 4. Phenolphthalein is colorless at any pH below 9. It changes color at around pH 9, and beyond that, it is pink in color. So we can make use of different colors to tell us when the endpoint of the titration has been reached. Given the many indicators that are available, how do we know which indicator to use? The best indicator for titration gives a distinct color change only when the equivalence point is reached. That means it can only change color within the pH values covered by the vertical portion of the graph. For this example, both phenolphthalein and Meta orange would be suitable indicators. Phenolphthalein is a suitable indicator because the color change is around pH 9, okay, and pH 9 actually falls within this vertical portion. Same goes for Meta orange. It is a suitable indicator because the color change also happens in the vertical portion of the graph. So in fact, all these indicators whose color change happen in the vertical portion would be suitable indicators for the titration. The only one that does not qualify would be indigo carmine because it changes color only between about 12 to 13, okay, and when it changes color, the equivalence point has been passed already and it will be too late. So for exam purposes, it would suffice to actually know two different indicators, Meta orange and phenolphthalein. And I think knowing both indicators would cover most of the different situations. So for the sake of O levels, just remember these two, okay? That Meta orange changes at pH 4 and phenolphthalein changes at pH 9. I think that would be great. Let me give you another example. The change in pH during the course of a titration depends largely upon the type and strength of acid and base used. What do I mean? Not all the time we use a strong acid and strong base titration. In the case of a strong base, weak acid titration, the pH curve would actually change slightly. As we can see, because it is a weak acid, and if this weak acid in the conical flask, the starting pH would be higher because it is a weak acid and only partially dissociates in water. And because we end off with a strong alkali, beyond the endpoint, the pH would be in a very alkaline range. For this example, we see that the pH of the equivalence point is actually not 7. is 9. And because of that, we need to choose an indicator that changes color in this range so that we know when to stop the titration. We see that phenolphthalein would be a suitable indicator. Methyl orange cannot be used because the moment a little bit of alkali is added, the pH would actually increase into the range at which methyl orange changes color. So it gives us a false indication of when to stop the titration. So for such a case, methyl orange cannot be used. Let me show you another example. In this example, we are having a strong acid titrated against a weak alkali. So in the conical flask, we have a strong acid and we see that the initial pH is low. Okay, as the alkali is being added, the pH increases, and again, the vertical portion of the graph tells us that the equivalence point is reached. This time round, we see that phenolphthalein is not a suitable indicator because it does not change color within the vertical portion of the graph. We can only use methyl orange. In summary, when choosing an indicator for titration, we first need to know when the indicator changed color at what pH, and we need to know the range of pH covered by the equivalence point. Choose an indicator that changes color within the vertical portion of the graph.